Assign co-host. No, okay. Rachita, if you go to the participant list, and once the participant list open up, if you go to like whom you want to give a co-host, you can assign there. It's not allowing you. Shan, is your microphone working?
It should be working.
Yes, it is working. No, I think Rosita said it's getting late in case our microphone continues to disturb. So you can start the session on time. That's what she says.
Yeah. More than happy to. And I'm sorry I got here a little bit late. Is there some issues with presentations? Sharing presentations? No, it's all good. So Rosita, your microphone is not working. Is that the problem? Okay. Still not working, Rosita. Okay, it's 11:01 Eastern Standard Time, and I know that many of our colleagues have joined us from all across the globe. Dr. Rosita Dara, who is the organizer of the webinar, unfortunately, she's experiencing some technical difficulties primarily related to her microphone. So as a result of that, she's not able to join us, but she can hear us and she can see us. So Rosita, if you would like to turn on your camera for a moment, if your computer is booting up, then don't worry about it. But if it's not, then yeah, here we go. So that's Dr. Rosita Dara from University of Guelph. And I just wanted to say that it gives me great pleasure to introduce myself and also introduce my colleagues here around the table, around the virtual table, two of whom are from my university, University of Guelph, and another from Wageningen University. And Cor, I apologize for sort of butchering the name of your university. But I hope that it was at least somewhat close to what the actual pronunciation should be.
It was perfect, actually. Great.
I loved it. But I know that you're too kind to me, so I appreciate it. So my name is Shayan Sharif, and I'm the Interim Associate Vice President Research for the University of Guelph. I just wanted to welcome all of you, all 68 of you from all across the globe, to this webinar. And today's title is Enhancing Adoption of AI in Agri-Food, a Path Forward. And as probably some of you have already seen in this panel, experts with diverse expertise will analyze the primary obstacles hindering the widespread adoption of artificial intelligence in the agri-food sector. And the panelists will propose measures to enhance the ecosystem, ultimately aiming for a more efficient, inclusive, and sustainable future. Perhaps as a way of introduction, I should tell you a little bit more about what I do and why this is important in the context of AI adoption, artificial adoption in agriculture and food systems. My portfolio oversees the Ontario Agri-Food Innovation Alliance, which is a collaborative initiative focused on advancing research and innovation in the agri-food sector within Ontario, Canada. And just for reference, Ontario is a vast province within Canada, approximately 1 million square kilometers with 14 million people. And we have probably one of the richest lands for agriculture in Canada and perhaps across the globe in terms of both availability of water and availability of the type of soil required for agriculture. And this Alliance program brings together several key stakeholders, including the Ontario government, the University of Guelph, and other agricultural organizations. And we oversee 13 research farms across this vast province of Ontario. And some of these research stations are focused on horticulture crops. Some of them are focused on field crops, and many of them are concentrated on a wide variety of livestock and poultry and equine. So we are really here at the service of research and innovation and also at the service of the people of Ontario. So having said that, let me introduce my colleagues here. I have Dr. Maria Corradini, who's an associate professor in food science and the Errold Chair in Food Quality at the Errold Food Institute at the University of Guelph. I also have Dr. Cor Verdo, who's a senior scientist at Wageningen University and Research in the Netherlands, who's specializing in business and supply chain informatics within the agriculture and food domain. And last but not least, I have my colleague, Dr. Asim Biswas, who's a professor and also a Canada Research Chair Tier 1 in Digital Agriculture and the OAC, or Ontario Agricultural College Research Chair in Soils and Precision Agriculture at the School of Environmental Science here at the University of Guelph. Dr. Biswas is also a member of the Royal Society of Canada. So we've been able to gather some of the movers and shakers in 3 different and very distinct areas that we are going to be focusing on in agriculture, on the spectrum of agriculture and food, looking at primary agriculture, looking at food, and also looking at supply chains. So having said that, what I would like to do is to start with Cor. And the first question that is common among all three of our participants, panelists, is what is the current state of AI adoption in agriculture and food? And I believe, Core, you have a presentation to make, and I hope that you would be able to load up your presentation.
Okay, thank you, Raj, for the introduction. I indeed try to share my screen.
And it's working. Perfect.
It's working? Okay, great. What I actually wanted to do is to start a discussion with three rather classical models for adoption. Yeah, as a food for thought, actually. And the first one is about the well-known hype cycle of Gartner. So the hype cycle for Gartner shows that new technologies go through first an innovation of a hype, so high expectations, and then through some disillusionments, they go to more mature applications. So if we talk about AI, it really matters what type of AI we are talking about. Also the current state, the question that you raised. Some types of AI, like computer vision, they are already rather mature and they are embedded in, for example, sorting machines or particular apps or other machines. And users often even do not realize that they apply machine learning, AI. So that's already rather advanced type of AI consumer adoption. While new technologies like generative AI, for example, ChatGPT, they are very much hyped and yeah, on the actually at the moment on the peak of the inflated expectations. If we talk about generative AI, ChatGPT, then yeah, it's incredibly how fast it was the uptake went. So in 2 months' time, they reached 100 million users. So that's really an very fast and for also for digital technologies. But does that really mean that this generative AI and ChatGPT also is adopted by the users in the agri-food sector? So that brings me to my second model, which is the model of Rogers in the diffusion of innovations, already introduced in the 60s. So yeah, and Rogers distinguishes between 5 factors: the compatibility, trialability, relative advantage, observability, and simplicity, complexity. So the perception of these factors is really very crucial for the adoption of new technologies and new innovations. If it comes to generative AI, I think that the main reason for its successful uptake is the trialability. So it's really very easy to experiment with it, to try it out. Everybody can use ChatGPT for free, and you can ask questions in natural language, and you can easily explore the benefits of this technology. On the other hand, the applications that can be tried out now are mainly related to chatbot like applications, generating pictures and things like that. But yeah, the phase we are now in is to explore how can it be used in real business applications. And that's still not very clear. And also the relative advantage of how can I apply it in my daily work, how I can integrate it in my particular business. There's yeah, quite some things to further explore and define. Also concerning simplicity and complexity, the usage now with ChatGPT is it's very easy to use, so that really helps. But how to use it in my daily work, that's another question. And that brings also me to the compatibility, which is a major concern of this type of AI, but also of others. So there are quite some open questions about, okay, how will this impact my labor, for example? What is the reliability of using these? Is it true what it presents in a very convincing way? What is the security, privacy, trust, but also intellectual property rights and many other questions that are behind the technology, and that's really crucial to address for the adoption. So what I think is that generative AI, they very quickly went through the first phase of adoption, but now the main challenge is how to go from the early majority to from the early adopters to the early majority. That brings me to my last model that I wanted to introduce to you, which is the adoption chasm of Moore. So he uses the different phases of adoption from Rogers, innovators, early adopters, early majority, late majority, and laggards. And his main message is that for adoption, it's really crucial to grow from the visionaries, the early adopters, to the adoption by the early majority, the pragmatists. And that's exactly the phase that I think generative AI is now in. So what's needed to bridge that chasm? It's mainly about proven applications. So how will this new technology be beneficial for my particular business? How can it be applied in such a way that that there's a good business case, that it's easy to use, that it's integrated with my other legacy systems, etc. So let's end up with some, let's say, challenges for adoption of AI that I think that are really crucial. One is to showcase industry-specific applications, so that are really understandable, explainable, easy to use, with a clear business case, and that are proven, so that there are use cases that are recommended by respected peers, that all the other conditions are arranged in a good way. The second point is that's really important to address the concerns that are now about AI in general, but also about generative AI, concerning reliability and truth, all kinds of fake content. Can I really trust on the outcomes of it? How's the logic behind it? So the results are often clear, but how are they produced? That's all. Too often kind of a magic black box. It's just like concerning security and privacy, IP and copyright, I already mentioned them. It's really important to address them to go to the new phase of adoption. And last but not least, a lot of the time in AI applications is related to the arranging good data foundation. So ensure that there's a robust data foundation with high quality data, well integrated, interoperable, including also a seamless integration with the other systems used in the firm. So that's what I wanted to introduce as an introduction to the discussion.
That was just wonderful, Cor. And I was looking at that animation and I was thinking, where exactly am I on that scale? I hope that I'm not, part of the laggards, asking, for the fax machine back. I hope that I'm somewhat, closer to the center, but that was wonderful. And just one housekeeping item. If you haven't seen the chat, please do take a look at the chat. Rosita has posted a note in the chat asking you to post any questions that you have right after the first question is done, and our esteemed panelists have provided their views. I would open things up and I would pick up questions from the chat, or else if you have questions that you would like to raise your hands, by all means, that can also be arranged. But bear with me for the next few minutes or so, and hopefully probably have answers to some of the questions that you might be wondering about. But having said that, Maria, you're the next person on my list, so please go ahead. And it's the same question.
Thank you so much, Ryan. So I think that it depends on also what kind of industry. I'm mostly work with the food industry sector. So I think that it depends on the industry that you're looking at. There are large companies have been using AI and other digital tools for over 20 years now. For example, in order to address complaints, and in many cases for food product development. I will share my screen for a couple of minutes in order to illustrate some of the applications that we have seen lately and some of the challenges and where do they arise. So I guess that you can see the screen now. So one of the major things that we are that happen with foods is the complexity of the foods itself, which also requires that when you are using any kind of digital tool, you have to collect a significant amount of data. But it's not just the food itself and the components of food, such as quality, safety, identity, and sustainability, among others, that make this adoption a little bit more complex, but also the complexity of the food supply chain. I think that Core emphasizes very eloquently how the complexity of the use and understanding what you need is something that affects the adoption. Something that is interesting is although there are a lot of complexities associated with food, there are several opportunities because, for example, in the case of safety, the amount of outbreaks related to food consumption, food service, and the food industry have been maintaining constant for almost 10 or 15 years. So we need additional disruptors in order to reduce the incidence and of these kind of problems in the food industry. Among the reasonable and more evident uses of AI lately, we have seen applications such as, for example, this one that we are advancing in my lab and in most of the labs that are doing food safety and food science related issues. We have been using AI, for example, in order to make more sense of the information that we are gathering from a single commodity, such as, for example, since we are in Canada, maple syrup. So I identify new techniques that we can incorporate into advanced models in order to identify problems with identity. This is a simple application and it's gaining popularity and it's advancing significantly. Most of the problems that are associated with this one is the amount of data that you need in order to create robust systems. That also plays in what Core was presenting in terms of proven applications. Many people are generating these kind of models, but they are not really proven applications that are fully generalizable because there is not enough information in order to, or the information is collected in a way that doesn't allow for that. Probably among the digital tools, some of the most interesting ones are the production or the twinning of physical objects to virtual objects. And most of us has been creating some kind of product avatar. Most of the modeling that we have been doing can be related to a product avatar. However, the communication between the virtual and the physical object is what defines them as being either just digital models, digital ghosts of digital, or actually twinning. As you can see here, these ones are some of the data that are being collected, for example, in my lab in order to put together a product avatar that is representative and that we can use for further applications. That requires a significant amount of data collection, a significant amount of knowledge in terms of modeling that allow us to have every process that a product will have, a food product will have, represented in the avatar as well, so that you can enact and enhance the applicability of this. And of course, additional sensing, which I didn't add it to this graph, that will allow us to facilitate the communication between physical and digital objects. So there are a lot of challenges, but I think that there are way more opportunities that will allow us for us to transition. And I think that in terms of the food industry, one of the major problems are data sharing and, of course, the training and the skills necessary in order to advance these digital tools.
Wonderful, Maria. And honestly, I have to admit, I had never even heard the term product avatar. So not only I learned a lot of interesting terms today. This was something, that's going to stick with me, for the rest of, at least for the rest of today, because my memory is also, shrinking by the day. So hopefully it's going to stick with me, for the rest of today. But Asim, last but not least, it's you. And would appreciate your views on this. And I don't know if you have a presentation, but if not, in a few minutes, in 3-4 minutes, if you can give us your views, that would be fantastic. Thank you.
Perfect. Thank you so much. Yeah, I'm not going to share any slides and bothering you anymore because we have been learning a lot in general AI adoption and others, but I'd like to take a little bit different view and tell you who I am and what we do and what AI can play a role, what type of role AI can play in my day-to-day work. So I'm a soil scientist by training. So all my degrees, my first job, second job, everything you talk about soil science, but then why the hell I'm talking about AI? So it's just a simple example I would like to give you. If you go to a doctor, before doctor sees, probably nurse sees you. And when nurse sees you, what they do? They take your body temperature. They probably take other signs of your body, like a blood pressure, anything like that. So that means they are gathering data. So before doctor sees you, doctor will look at those data, the signs, and they will try to talk about what is happening. This is one example. So that means we are looking at a lot of data. And in my lab, we have been developing different sensors and bringing up AI and technologies to actually collect soil samples and soil data. The other thing is that now what type of a sensor we can work with? Think about like even 20 years ago, 10 years ago, when we talk about if I'm a diabetic patient, I need to take insulin. What I would do, I would send my blood sample, analyze them from the lab and get the data. Based on that, I'm going to take insulin. But I think that's way too late to take a decision. For any decision making, it takes a long time if the data comes late. So what happened? Nowadays, you can go to a pharmacy, you can get a small sensor with a pinch of your finger, you can get the data on your blood sugar level. And based on that, you can take a decision whether to take an insulin or not. Why not we do the same thing for soil? Why should we take a blind decision making for soil in terms of a fertilizer application, pesticide application? Data could help, the sensor, AI, and other development in the technological space could help you. And those sensors, I don't have to be sitting those sensors in the lab. Can I take those sensors right out in the field, measure properties, and take an instant decision making? That's why my lab, my research team works on developing data-driven solutions. So we need data to make decisions. And how do you collect data? In a traditional way, probably it's way too costly, expensive, time-consuming, laborious. We'd like to develop sensor that could give you instant measurement. And in this aspect, we do develop various IoT sensors, Internet of Things or Internet of Everything nowadays is coming up. And with an utilization of machine learning or even artificial intelligence, different kind of artificial intelligence model. And we sync that with the natural intelligence, our understanding of what soil is, how water moves in the soil, how nutrient stays in there, how plants grow in there. So really in that space in my lab, in the program Digital Agriculture, we are seeing how digital technologies and AI could actually help us in our day-to-day decision making. So in this context, if I say where we are now in the adoption of AI in agriculture and agricultural production, we have seen a lot of advancement in terms of the sustainability and precision agriculture. So that means we don't want to just you don't want to take all the medicine that are available in the pharmacy. You take the very specific medicine required for your ailment you need. So that means we would like to provide very precise information, very precise crop input that a crop need to grow more food. And that's what we call as the precision agriculture or prescription agriculture. the same way. So now when you are putting more precise application, you are not wasting those crop input. You are not allowing your agricultural feed to leach those nutrients to the groundwater or maybe surface waters as well. So you are really looking at the sustainability aspect of as well. So the environmental protection, environmental health monitoring, you can do with an AI technology. We have been using a lot of AI, and in that case, sensor, GPS technology, drones, even the satellite data we have been using to monitor where we are. A lot of digital transformation. We have seen agriculture sector like digital revolution leveraging AI, IoT, the sensor I was talking about, even the blockchain. Like when you are producing something, we'd like to see where things are growing, where it is going for the marketing as well. So the blockchain to improve efficiency and transparency as well. Traceability, I know in the food aspect is a lot more important, but agriculture, we need to understand where it is growing, then we'll know what that food is carrying. Same way with an AI is helping us to meet the labor challenges. I know like at least the COVID time taught us a lot that the challenge. We have been facing the challenge of labors, and I think AI and robotics are actually helping to meet some of those demand as well. And whenever we're looking at this AI, we are trying to take a look, the case study. For example, one of the many program around the global going on, like AI for agricultural innovation, like really utilizing sensor to make a decision when to actually put irrigation water or when to put the fertilizer, if we can actually monitor that, or even some of the other things we're using, even listening to the birds and insects, the sound, we can see what is the diversity, what is the biodiversity of that particular field, and how we are enhancing that. Again, a lot of opportunities are there. As Maria was saying, the opportunities are more than the challenges. But again, I would like to say, along with the food challenges in agriculture, we also do have a lot of challenges, agriculture, ethical consideration, which in the last webinar we discussed on that. But there are challenges, there are privacy, and many times when we are working with the growers, working with the farmers, a lot of issue about the data sharing, privacy, and other information coming in. But I think we'll talk more about that. I just want to give a quick overview what we do in our research and how AI being integrated in adopted in our day-to-day research. Not only that, and translating that into a practice. I'll stop here, Shan.
Wonderful. That was excellent. And what stuck with me, in addition to some of the really interesting things that you've already done, you also talked about some of the things that can be done, such as, for example, having a better assessment of biodiversity and how biodiversity could impact agriculture. It's just mind-blowing what can be done. And I think, we need to move forward. We can't really be stuck, in all of the challenges, because, when you think about all of the challenges, there are just far too many of them. But I think in terms of opportunities, there are also a lot of opportunities that we haven't even touched upon. So I'm just going to go through some of the questions that are posted here. There was one housekeeping item for Dr. Dara, and that was related to presentations and whether or not they're going to be available after the sessions. But I'm going to leave that to Dr. Dara to respond perhaps in the chat. There was one question about AI and the use of AI in monitoring crop health. And I think, Asim, you talked about that rather extensively. Is there anything that you would like to touch upon, or you think that it's sort of, been addressed?
Addressed in the sense in our work, the way we're trying to take a look, not only on the ground based some of the sensors we're taking on, but there are challenges like, before I go to challenges, like the way we are trying to put the cameras, like trail cameras and others, to observe what is going on in the field. And those camera images are being processed to see the changes and developments and the challenges arising on those fields. But also at the same time, we have been utilizing drone to get actually for the overall picture of the whole field. Earlier days, it was more of a crop scouting. You walk through, you drive past and see what is going on in your field. Like again, if I start talking about from a large scale perspective, but I do work in the both context, very small holding farmers. How do we manage piece by piece small fields? At the same time, large scale commercial funding, commercial fields, commercial farms. In those cases, like we are using those large scale drone images, trail camera and others. But again, from a small holding farmers cases, we are also taking on like a cell phone images. We are actually taking a photograph of a crop plant and see what the challenges might be. Again, these are not as accurate as should be. I'm telling you, like it won't be exactly the same that you take a leaf and see what deficiencies we have. But probably I do not need that. If it helps me with a 90% accuracy or 95% accuracy, help me take a decision and protect for further loss of crop or the plant growth, I am happy with that because I can make a decision. So this is why we're using cell phone technology like a smartphone to take a photograph. It processes the images and tells you what is the potential challenges it might have. For a large scale farming, we're taking the drone images, some trail cameras, and even try to connect back with the high resolution satellites, which are not free. It is quite expensive, but we're trying to get to a free images like Sentinel-2, which is a 10-meter resolution, 8-day interval or 6-day interval sometime. So that's how we can also work on the scaling up. But this AI is really translating those information, like whether it's an images, whether it's any sort of strains on the leaves, and how do we translate those images into information and further to the decision making. I think that's why the crop health monitoring we have been utilizing a lot of this image-based sensor, and like it's a computer vision rather than human eye. We're trying to see it through the digital eyes and digital lenses, and we take those images as the vision, and then we convert them with an AI to actually make a decision make or convert into an information that could be translated into decisions.
Wonderful, Asim. And you probably also answered my own question, which was in regard to, what we can do for subsistence agriculture versus, more commercial, large-scale agriculture. But you answered the question, one question, but you answered a lot of other ancillary questions to that. So let me go to the next question that is in the chat. How big data analytic can help in food supply chain alongside AI? So the question can actually apply maybe primarily to you, Kor, but it can also apply to any of you, Maria and Asim. But maybe we can start with you, Kor. In terms of big data analytics and combining big data analytics with AI in order to make better decisions in food supply chain.
Yeah, thank you. So actually, I always distinguish between different types of analytics, starting with descriptive analytics, having dashboards and key performance indicators in which you monitor the what's actually going on in the models in the supply chain. Then you can go to more diagnostic analytics, in which you also assess the cause of things that are going wrong, and then the predictive analytics, in which you also forecast and predict how it will be in the supply chain, and then up to prescriptive, and then in the end really autonomous system. So that's all about data and combining data in the supply chain, and then analyzing it with the algorithms to really have management information out of it. So AI is part of that puzzle, and that is especially applied for predictive analytics, but also prescription to autonomous systems. So I do see AI as a part of the analytics applications that are possible in the supply chain. For example, I worked in a flower supply chain, and then we started with basic tracking, tracing, and monitoring where the flowers were transported. And then we connected it with sensor data, and based on the sensor data, you can also monitor the temperature and other characteristics. And then you could also analyze the causes of the vase life that was dropping down. What is the reason of that? And from that on, you could connect it to let's say optimization models, prediction models to prevent issues in quality management in the supply chain. So there's actually a range of applications that could be done in supply chains, in which the more advanced the applications are, the more use of AI is there. I hope this answered a little bit the question.
No, I think it was right on. So thank you very much, Cor. I don't want to put you on the spot, Maria, but would you like to chime in here and provide maybe your view on this, if you feel that this is sort of within your wheelhouse?
Well, I think that Cor make a very good summary. One of the things that I would like to add is that in the case of the food industry, the amount of data available is really impressive. And actually it's a missed opportunity because we are not using at its full potential. So the applicability and the user-friendly options that AI provide might allow us within a company to use the data better, for example, in order to factor in, for example, one of the things that we have proposed is use AI in order to assess actual efficacy of training of users and operators within a factory in order to enhance training. So things like that within a single company, that would be really helpful. I think that everything depends also on governance and how much people are willing to share in terms of data in order to make AI results more robustness and generalizable.
Excellent. I think in the interest of time, I'm just going to have to maybe skip over a couple of questions here and there, but we will definitely try to come back to them. And just Asim, there is a question about using AI per hectare. If you wouldn't mind maybe posting your answer in the chat to this question, that would be great, because probably just a number is required, but I'm sure that there's a lot more that you need to process and analyze before you can answer that question in the chat. There is one question in regard to regenerative agriculture, which I'm going to come back to in a second, but there's a question for you, Maria. It says, do you believe AI models would take over traditional mechanistic-based models in industrial process applications? So AI models versus mechanistic models.
Well,
Which one is going to take over?
Yeah, I appreciate Dr. Karchofis from UC Davis for that question, because I think that is something that we all we are trying to figure out, if AI will replace a mechanistic model. From my particular point of view and my preference, of course, that AI approaches usually are considering kind of black boxes and to a certain extent cannot replace a mechanistic model. But actually, I think that hybrid models is one of the best ways to go. We can use AI, for example, to fill data gaps. We can use mechanistic models in order to gain a better understanding of the underlying principles of a particular process. So I think that the combination and hybrid models is going to be the way to go.
Okay, that was great, Maria. Short and sweet. So I guess I'm just going to have to open a bit of a can of worms here to talk about regenerative agriculture and the use of AI practices related to that. Asim, are there some use cases for the use of AI for regenerative agriculture?
Yes. So again, I don't strongly say yes, but there are some of the examples and a lot of movement going on in terms of quantifying the change. So basically, unless it's simple in regenerative agriculture, when you're trying to adopt a practice that could actually help us regenerate our natural condition. So if I want to say regenerative agriculture in that context, so even the change, how do you actually quantify the change? If you are making a right decision to go forward or not, even the efficacy of the practices you are taking. So the example I was just giving in terms of that's in a regenerative agricultural field, we're looking at the diversity of biodiversity of different insects, birds, and others. So basically, we have the mix of like a natural grassland condition with an agricultural field, and would like to see in different land uses, what is the diversity? And we are putting together the sound monitoring sensors that could monitor the sound and using an AI to actually differentiate the sound in terms of how many different insects are actually singing or how many birds are singing. That's probably clearly tells you what is the land use surrounding it. That means what is the habitation these particular land uses are providing and how that's increasing the diversity. It's a very simple example of how we are using AI in a regenerative agriculture, the performance of it, the efficacy of it. The other one is a lot of movement going on with the regenerative agriculture. We know the soil carbon content is changing, soil organic matter storage is changing. How do we measure it? If you want to do a traditional measurement, it's not worth it. We can't actually afford to do it. Can I bring the sensors like IoT, IoT, and AI? So in that space, how do you actually enhance that measurement? Even a lot of space, the movement are going on in terms of creating measurement verification and MRV system, measurement reporting and verification system for soil carbon measurement. So in a regenerative agriculture, whether the performance monitoring, quantifying the efficacy of it, or even the AI modeling in terms of what is the best management practice that could help us improve the biodiversity, reduce the greenhouse gas emission, or even increase the carbon sequestration, or we are using another project we just completed, how this vision and AI technology we can see or we can utilize to monitor the soil erosion. Soil erosion using from the gullies actually creating a lot of problem in the downstream water quality, particularly Lake Erie. We're in the southern part of Ontario, and Lake Erie, we're in the middle of June and July, you will be hearing a lot of issues about the Lake Erie water quality. So we're trying to see even this AI through visions and modeling techniques, AI modeling techniques to quantify or even identify and then try to simulate what are the best management practices could be most suitable to reduce that erosion. So these are some of the examples, again, thinking about from a regenerative agriculture point of view, how AI could be utilized in there. Some example from my work.
That was just wonderful, and it does actually tell us a little bit more about how important AI has become for not just some, I would say, mainstream agriculture, but also other components of agriculture. And also there are some questions about the use of AI in livestock industries, which is probably not within the wheelhouse of our panel, but more than happy to talk about it if time allows. But there are three questions that I would say, I can categorize them in terms of the question from Corey, from Roger Larson, and from Juke. The three of them are looking at information around AI and machine learning and the fact that people probably have some misconceptions. They feel that these are black boxes, nobody understands them, and because nobody understands them, might as well be scared of them. Then the question of economic aspects of adoption of technologies, AI as one of the technologies. And then the last question, which I think is along the lines of what you described, Asim, in the beginning, or perhaps it was also you, Cor, who described this, in terms of how technology can be adopted, given the fact that people simply don't have the means to do it, because they have smaller farms, and as a result of that, they can't really adopt those new technologies right on the spot. So maybe in their mindset, they're the early adopters, but they can't really adopt the technology because it's so cost prohibitive that they can't really adopt it. But having said that, how would we be able to combat some of the maybe misinformation or disinformation around machine learning and AI? And what are the economic sides of things, aspects of adoption of AI? Maybe I can start with you, Cor. Give me your view on adoption of AI as the main core of our business in agriculture and in food.
Oh, that's a large question. As I introduced in the presentation, I think that making the move from just talking about AI technology in general to concrete proven application, that's a key issue in having this adoption, and also to address the feeling of that it's a black box and a lot of magic is going on, and can I trust the results of it? So I do really think that just having concrete applications and also showcasing them, having peers that explain how it works in their situation, that's really crucial for that. And furthermore, also from in AI, there's a whole development going on for explainable AI. So I want to mention that also. There are tools and techniques that could help in understanding what the reasoning is behind particular AI applications. And that could also be helpful in addressing the black box feeling.
And along those same lines, and I don't want to interrupt the flow of conversation here, but what would be the role of, for example, universities and collaborations between universities, industries, and governments to help and lubricate the process for adoption? Because, part of it is really, dissemination of knowledge. Part of it is making things more user-friendly. Part of it is funding. What are the sort of things that we can do to help the process? All five of us basically are from universities, and we have our finger, in an academic environment. What can we do to make things better?
Shall I answer?
Please.
Yeah, I do think that if you look to adoption, it starts with ideation, experimenting with new technologies, prototyping. And I do think that universities could be a valuable partner in those types of innovation projects. So then also, if you look to the question about smaller companies that lack particular AI experts, being part of an ecosystem, a digital innovation ecosystem, could be really a way to go there. And universities can be a valuable partner in that. And they can also help to provide evidence, for example, for the cost benefits decision. And a very nice example of that is in our university we did and is still doing a challenge about autonomous greenhouses, and there we have several teams that manage the greenhouse based on AI technologies, and a reference group of experienced growers that and all the teams are assessed based on their economic performance, but also on sustainability. And in those challenges, the winners and most of the teams, they even outperformed the reference group of experienced growers. So those types of challenges and innovation events are really helpful in creating the awareness of what AI could, the impact could be, how it could be used. It really helps to increase the adoption.
Wonderful. And there's a comment here, better to give certificates. So and maybe you do actually give certificates, but anyways, Maria and Asim, do you have any further thoughts about this? How to demystify machine learning and artificial intelligence, and how to ensure that they're integrated, and what are the sort of roles that us in universities can play alongside our colleagues and friends in the government and also in the industry?
Yeah, I think one of the challenges there, breaking ice is always a difficult thing. So, and that breaking ice, so when you talk about the AI technology, and I can see some of the comment, 30 years ago when you're talking about precision ag, like when first time the GPS came, like in 80s, and we started to put on the tractor, the major precision we tried to do, can we drive my tractor straight line so that all my management operations are good? That's 80s precision ag we're talking about. Then in 90s, 2000, when you're talking about the sensors coming in, a lot of farmers, they were sold to those things, and they put it on the tractor. Probably they never used it. And I've seen many farmers, when you talk to them, they bought yield monitor probably 15, 20 years ago. And did I ask, how did you use it? Oh, I don't even know how the data is. So basically this lack of this knowledge and the training support and some of those things, and really showcasing that success story, I think this could really help us demystify, okay, what are the challenges now you're gonna, and what role the academia can play. It could be a training program, it could be like showcasing the success story through different case studies, or even the peer network. Like I know many times when I talk to the farmer, the best time is to go in the evening over a beer. And rather than you as an academic talk to them, I often find they listen to their colleagues, they listen to their group mates, and they talk to them. And I find this peer network are more easier to actually breaking those ice much easier than as an academic or as an industry professional. The success story, as in, like, again, some of the other challenges is that, like, if I give you a new technology with a complex dashboard and system, and there is a not interoperable, it cannot actually attach to my existing resources or existing machineries. I don't want to spend like another $5 million in changing all my things. So these are some of the challenges as an academy, as an industry. We really need to think about how the new challenge, a new technology, whether it's an AI and the sensors, could actually attach to the existing resources. It's not, I don't want to change the whole thing overnight, but how do we make that gradual change? I think these are the very real problem I have been facing, like when you talk to the farmer working with them. So taking that baby step, taking that small step could help like demystify those and this success story, talk to the peers, and of course some of the financial incentives. Like I've been talking about, in Auto a couple of times we talked about, can we create some incentives? Like it could be a tax rebate for the growers, it could be some of the other things. Like how do you motivate them? I always believe that philosophy, like you follow something, you do something. If there's a regulatory, that means somebody tell you, oh, this is a law, you should do it, or there is a reward to do it, something like that. If it is given a reward through finances, like through rewards, like in terms of tax rebate and other things, could be helpful actually bringing up the adoption of the technology in there. And
Wonderful, Asim. I'm just going to stop you there because I think you hit the nail on the head. I think that's a really critical part, at least from my point of view. I'm not a regulator, but I think, that could be, one of the big things for the future, especially, when we're thinking about expansion of integration of technologies, either AI or other types of technologies. But Maria, you've been patiently waiting, so please
No,
chime in.
that's okay. Yeah, actually. So I would like to call attention to something that implicitly Core and Asim were touching on, that is validation. One of the things that is extremely important and is it should be incorporated in any kind of technology that you are developing, any digital tool, any modeling technique, is the appropriate validation. And I think that sometimes because of the rush that we are moving into, sometimes we don't pay enough attention to the validation step, which is key in order to make sure that these technologies not only work and are applicable not only for a specific problem, but they can be expanded, but also in order to create a perception that we are not dealing with something that we don't understand. So a validation step is extremely important. And I think that training and exposing our students to the development of these kind of approaches and techniques is extremely important for them to try to apply critical thinking when they have to use the technology, but also when they, for example, they get a result and they have to make a decision based on the data that are that is being generated. These technologies are significant in order to support decision making, but also, we have to always to use critical thinking in order to see if the results that we are obtaining make sense and are not creating with a tool that has not been appropriately developed or validated.
Yeah, so that's wonderful, Maria. And I think, that talks about de-risking, the endeavor, the business, proposition that a producer would have to think about. And I guess, it depends on the size of their operations, small or large. I think, what we're going to have to think about for the future is the application of AI and other sorts of digital technologies, not just for the large holders, but perhaps, for the small farm holders as well. And not only here in Canada or perhaps in North America, but across the globe. And I think, that was probably, one of the messages that I'm going to take home with myself, that, it's basically work in progress. But what we are going to have to look for in the future is how to incentivize the process for farmers and ensuring that everyone in some shape or form is incentivized in order to adopt new technologies. And it's up to us in academia and us in government and industry in order to be able to de-risk that endeavor and that proposition for the farmers. Otherwise, they would not be able to adopt the technology. I'm just going to go back to the question that Roger Larson asked, and I'm just going to maybe put it sort of black and white. In Canada, and I know that many of our colleagues are joining us from across the globe, so I don't want to make this a Canada focus or a Netherlands focused webinar, but given what we know now, are we actually at this stage that we could say, both for field crops and for horticulture crops, and perhaps for livestock, we've reached a point that we think that we have enough incentives and we've de-risked many of the technologies to the extent that they're ready for adoption? Are we actually at that stage yet? Maybe I can start with you, Maria, because I know that in food industries, probably there's more infusion of AI and digital technologies in the process of food production and packaging and stuff like that. What is the level now, and where do you think we're going to be going in the not too distant future?
Well, in order to bring it to the initial part of core presentation, I think that, for example, machine vision is something that is omnipresent in the food industry. And most of the equipment is already is already attached or control. It has some controls that use machine vision in order to optimize performance, develop some kind of sorting, and even identify if something has gone wrong. So in that sense, that's pervasive and fully and widespread. There are some other things that are not as applied. So when it comes to simulations and modeling, for example, using digital or digital twinning, that's not something that the industry has done so much. And it has been applied mostly for post-harvest and distribution. And I think that Ascor has published significantly vertical farming and that kind of applications, but not, for example, for the full processing. There are digital twinning for some specific processes, but not extensively applied. And I think that it has to do also with data governance and willingness to share information. And I think that we have to emphasize that it's upon the user what you want to share. So it's not that you have to reveal all the secrets of your company in order to make the process work.
Okay, wonderful. And I want to invite Cor and Asim, maybe in, I would say 20 to 30 seconds each. If you can provide your comments, that would be fantastic. Much appreciated.
Yeah, no, I just responded quickly to Roger's, like, yes, we have been doing a lot of economic analysis of that. And I think the other solution we have been thinking about, like, really that high cost associated with the production agriculture, like, how do you actually mitigate that? How do you take into account? I think the one I was mentioning about some of the grants and subsidies program and tax rebate and other aspects, some of the cost sharing initiative could be done, or even leasing and financing. When the technology is costly, there could be leasing or financing options, or even the technology service provider. I know there was a question I saw, like, what will be the role of human labor in that case? And true speaking, as the technology is moving forward, we're not losing labors. We are actually requiring more and more human resources to bring it back, because that could be technology as a service. We can do a collaborative research and development to showcase that. I think there are other aspects coming up. How do we actually build that one, and how do we take care of the economic aspect? Yeah, 30 years ago, when you're talking about high value crop, now we are doing day to day on a field crop activity like corn, soybean, and we're all talking about this technological adoption here in Ontario as well. So I'll stop quickly there. I know we're on the time.
All right, that was wonderful. And Cor, last but not least, your comments.
Yeah, yesterday I was actually at Green Tech in Amsterdam. So there was a lot of AI presentations, nice tools. So I don't think that the state of technology of AI is the main issue for adoption, but there are other factors, including, for example, digital readiness, And also, the other factors like what is the impact on labor that was mentioned. And it was a nice quote of one of the early adopters that was trying to sell the solution to let's say the early majority. But it said, don't consider AI primarily as a threat, but as a new colleague who is going to help you and who allows you to focus on the real interesting stuff. So the focus shifts by AI to, for example, cultivation strategies or the real things that matter instead of a lot of boring work.
Wonderful. And I think I couldn't have completed this webinar and discussion without my esteemed panelists. And I think the last quote was quite appropriate, and it was really right on. So we are going to be looking at AI as a colleague who's going to be helping us, with our daily life and also, with some of our future endeavors. So let me thank all of our panelists for their wonderful contributions, and also to all of the participants. I think we reached approximately 99 or 100 all across Ontario, Canada, and globally. So thank you very much for your attention. I believe Dr. Dara wants to wrap things up.
Can you hear me?
Yes, we can hear you.
Okay, so hi everyone. My apologies that I couldn't turn on my microphone. I'm joining through my cell phone. I was worried that if I leave, although Cheyenne is a co-host, it will get disrupted. But just wanted to thank everybody, all the attendees for your time joining us today, especially the panelists. It was a very engaging and very informative session. Thank you very much, Cheyenne, for a great job you did moderating the session. Just wanted to let you know, this is part of the new initiative at the University of Guelph, this webinar series on artificial intelligence and food, agriculture and food. We jointly co-organized this with Wageningen University Research, Paul Ramos, one of CORE's colleagues. We have one more session left. I have posted the link in the chat. We look forward to see you next week, again, the same time. That will be the last one. But please stay tuned. I will share our website for future events in the fall, this coming fall. Thank you very much again for joining, and have a great day. Thank you.
Bye, everybody.
Thank you so much, everyone. Bye now.
Recording